Bismillahirrahmanirrahim. Today I'm going to start with the reactive dyes, vinyl sulfone-based reactive dyes. In one of the previous lecture, I've given you an introductory overview about the reactive dyes, where I told you the reactive dyes could be of two types. The one is called cyanuric based reactive dyes, the other are called vinyl sulfone based reactive dyes. Before explaining those classes, I gave you an overview what the reactive dyes are. Reactive dyes in fact are those dyes which make permanent bonds with the surface of the fabric. Permanent bond means they develop a covalent bond, means one of the functionality on the dye reacts with the hydroxyl group present on the cellulosic fiber, and the reaction results in the formation of a permanent bond between the dye and the hydroxyl groups of the cellulosic fabric fiber. So this is how the reactive dyes do react with the surface and get fixed permanently. In my last lecture, I have explained reactive dyes which are prepared using cyanuric fluoride. This is a structure of the cyanuric fluoride, trichlorotriazine. This is cyanuric fluoride. It reacts with those dyes which carry some sort of polar functionalities, like hydroxyl is there. If some dyes carries amines, then one of the chloride from the triazine is replaced by the hydroxyl group as a result of nucleophilic substitution reaction, producing this sort of the structure where dye has been connected with cyanuric fluoride, and this will be called as a reactive dye. The presence of two chloro groups in the final product, reactive dye, they are still available to react with the hydroxyl group which are present on the cellulosic fiber. So they will react with the cellulosic fiber to make bonds with the fiber. So as a result, this dye molecule will get fixed on the surface of the fabric molecules, fibers. So what has happened over here? This cyanuric fluoride is acting as a linker. It acts as a linker between dye and the between the dye and the cellulosic fiber. So those dyes are called reactive dyes, and specifically the cyanuric fluoride based reactive dyes. As I've told you, the dye could have some sort of hydroxyl groups, or it could carry some sort of amines. So those amines do react with cyanuric fluoride under nucleophilic substitution reaction, giving us dye molecule carrying cyanuric fluoride functionality, which still has the capacity to react with other two nucleophiles, and those are supposed to be from the cellulosic fiber. This is how these reactive dyes are prepared, and they are made to react with the cellulosic fiber. So this is one of the class of the reactive dyes, which is cyanuric fluoride based reactive dyes. I explained it in a bit comprehensive detail in one of my lectures, that is reactive dyes, where I've explained the reaction of this resultant reactive dye with the cellulosic fiber. I have explained how the permanent bond has been developed between the chloro groups of the cyanuric chloride and the hydroxyl group of the cellulosic fiber. So next today's I'm going to discuss this class number 2 of the reactive dyes, that is reactive dyes based on vinyl sulfones, What is vinyl sulfone? We have an ideas. This group is called sulfone, this is called vinyl, and this R is supposed to be a part of dye. It is supposed to be a dye molecule, Then this will be called as a vinyl sulfone-based dye. Like this, or I can represent it this way. Let's say it's a dye molecule carrying sulfone and then here vinyl functionality, that will be the vinyl sulfone based dyes, and they will be acting as reactive dyes. Why they are called reactive dyes? Because it has the capacity to make bond with the, I can draw this way, cellulose fiber contains hydroxyl groups. When they come close to the vinyl sulfones in the presence of any base, we got the ideas. The base are present. The bases could protonate, could take this proton away, making this functionality a bit more nucleophilic in nature. Then the reaction between over here and then the subsequent additions of proton results in the formation of something like that. It's a cellulose. So this vinyl functionality has reacted with the cellulose. I should write this way so people can see it easily. Cellulose. Yes. So cellulose hydroxyl group has reacted at this CH2 position, and then you have carbon, this carbon. So the vinyl sulfone based dye has reacted through a covalent bond with the cellulose. So due to the formation of this bond, this dye is supposed to be called as reactive dye, and this reactive dye is basically a vinyl sulfone based reactive dye, because in previous case the reactive dyes were supposed to be based on cyanuric chloride. Over here the reactive dye is supposed to be based on vinyl sulfone, So this is how they are supposed to be. How the vinyl sulfones are introduced on the dyes, what sort of the dyes are look like, how they are, what could be the structure of the dye, That is a vinyl sulfone dye. I can give you a brief overview of the dye. Dye could be of any type, especially the Azo dyes. Let's say we have started off from the aniline. We performed the diazotization and then we coupled it, Then we coupled it with, let's say we coupled it with phenols. also carries the vinyl part, vinylic part, so dye could be of this type as well. How this gentleman has been introduced, it's a subject of another next lecture, how the vinyl sulfone are attached to the dyes, you know. Similarly, let's say somebody would have used this could be vinyl sulfone dye produced from H acid, you know. So what is the condition? We need to have a vinylic part along with sulfone group, vinyl sulfone part. As soon as they are present, whatever the rest of the structure of the dye is, that dye is supposed to be called a vinyl sulfone reactive dye, you know. These are the two examples I've just given you. On a lighter side to know about the vinyl sulfone based dyes, and these two dyes belong to the Azo class, you know. The dyes could be non-Azos as well. If you have prepared the dye from the alpha naphthalene, you know, a non-Azo dye, non-Azo vinyl sulfone based dye, you know, it could be something like that. So rest of the structure of the molecule could be anything, either Azo or non-Azo dye. However, what is the requirement is, that is the presence of a vinyl sulfone group, you know. If this group is present, then the dye is supposed to be vinyl sulfone based dye, which could be applied on the cotton fabric, where cellulosic fiber will undergo a nucleophilic reaction with the vinyl part, giving us a permanently fixed dye at the surface of the cellulose fabrics, you know. As the bond formation will be a covalent, permanent, those will be called as the reactive dye. Now let me explain how the vinylic part is introduced on dyes to make them vinyl sulfone based dyes, you know. As I've told you, this functionality is a vinyl sulfone based dye, you know. It is produced by 2-3 different methods. One of the very much known, a frequently used method is based on epoxide, you know. This method is used where it is reacted with the lithium bromide and then some sort of sodium sulfate salt, you know, that is used. In this specific case, this is supposed to be R is a sort of a part of a dye molecule. I will explain it later, you know. It is going to, we can call it R1, we can call it an R2. So this lithium bromides, this is a metal. Metals are always electron deficient. It develops its interaction with the oxygen of the ring, something like that. Due to the attachment of this one, interaction between lithium and oxygen, the bond between carbon and oxygen becomes weaker. It gives a chance for the lone pair of the sulfur to attack on this carbon, So resultantly what happens, this ring undergoes an opening, a ring opening reaction happens there. So what is there? We have R1, here is S, something like that. Here is the R2 from this side. And here is supposed to be the oxygen of the one from the hydroxyl group, the one which has come from the opening of the ring, supposed to carry the positive negative charge, having a sort of interaction with the lithium bromide. At this moment of time, we could introduce, due to the introduction of water, in fact it becomes hydroxyl OH, and then what happens there, it opens up like this way. This open up this way, the ring of oxyrane has been opened up into OH, the one which is connected with the lithium. This interaction between lithium and oxygen results in the opening of the ring, giving us this sort of a structure due to the involvement of a water. The open ring over here, then what happens, this hydroxyl leaves when a proton which is already attached is this carbon. It is abstracted by the base, and those electrons are moved to make a double bond, and then this hydroxyl is removed from here. Resultantly what happens, we will have R2, and then we will have over here we have another R1, and a double bond is supposed to get generated over here, that is in the form of vinyl group, so it is supposed to be the structure which carries vinyl sulfone. This R belongs to the epoxy ring, epoxy ring, and this R2 which has come from this molecule. So as a resultant, we have a vinyl sulfone present in single molecule. Now if this R2 has come from some sort of a dye, if it's a part of some sort of a dye molecule, then this whole structure will become a vinyl sulfone-based dye. It will become a vinyl sulfone-based dye. So this is one of the method, one of the way you can use to prepare vinyl sulfone-based reactive dye. I can explain it again for you guys. We are starting with any epoxide ring, If you have this sort of a compound, we put in lithium bromide, and we have some salt of sodium sulfate salt from the organic compound. In this very specific case, it is supposed to come from some sort of a dye molecule. I can explain it further how it can be introduced on a dye molecule. This lithium bromide, lithium being a metal, can have an interaction with oxygen of the ring, making this bond a weaker one, creating a chance for the lone pair of the sulfur to attack at this carbon. Resultantly, the ring opens up, leaving of this proton, then these electrons are moved to make a bond between carbon and carbon. Resultantly, this hydroxyl group is removed, which finally generates sodium hydroxide, due to the presence of this sodium in the beaker in the same reaction media. And as a result, the double bond is generated. The generation of the double bond produces vinylic functionality. The sulfone group is already present from the starting molecule. So this is called a vinyl sulfone-based compound. However, this R2, if it belongs to a dye, then it will be a vinyl sulfone-based dye. I can give you an example of a vinyl sulfone dye formation. Let's say we have this sort of a molecule. It's an vinyl sulfone based and Azo dye. It's an Azo dye, acidic Azo dye, because this is an acidic group present on the dye, and this is an Azo group. So this will be a dye. If you just consider this one, and we mark it as R2 in fact, because R1 is from the ring, Then this R2 could be connected over here. This R2 will be a part over here, R2 will be over here. It will look like something like that. They are matter to each other, so there will be nitrogen in the form of an azo. So this will be this sort of the compound. Same will be here, so I can write the final product as it will look like, So this is supposed to look like having substituents on metacarbon. So it is supposed to look like this one. So now it's an Azo dye having sulfone group. Secondly, it also carries a vinylic part, vinylic functionality is there. So it will be a vinyl sulfone based and Azo dye. Now, if someone brings in, if someone brings in cellulose having hydroxyl functionality, as I've just explained a minute earlier, they react with each other in the presence of a base. So what happens really, I can draw at the same position, reaction over here. So you will have the product like cellulose hydroxyl have attacked at the vinylic part. So it is C1, this will be the C2. It's a vinylic carbon. Vinylic functionality has been reacted with the hydroxyl group of the cellulose. So one of an azo vinyl sulfone based dye has reacted with cellulosic fiber. As the reaction has resulted in the formation of a bond, this is the bond which has been generated, which has been produced. So the dye molecule is supposed to get fixed permanently on the cellulosic fiber. So this is how the reactive dyes, which are vinyl sulfone based dyes, they do react with cellulose, and this is how they are generally produced. How these epoxides are produced, all these rings are produced, it's another story, can be discussed in another lecture, how they are actually produced and further made to react in this way to give us final vinyl sulfone based dyes. So this is one of the reaction, one of the way that the vinyl sulfones are produced, However, I have another very simpler reaction as well, very much known for the production of vinyl sulfone dyes, that can also be discussed for the preparation of. According to another known method where vinyl sulfones are produced, the starting material, the starting molecule looks like this. If you put in a strong base, the base abstract the proton from here, and then these electrons are moved over here to generate a double bond. Resultantly, this bond is broken. The group is supposed to be a sort of a good leaving group. Then we can have the vinyl sulfone entity, vinyl sulfone group functionality could be introduced. Again, this R is supposed to be from some sort of a dye molecule. It is supposed to be some sort of a dye molecule. Let's say one can presume, I'm just giving you an example, that we have this sort of starting material. We have sulfone group. We have this sort of groups attached to the carbons. So it's a sort of a dye, which one can call it an R. So if we react it we introduce, some sort of a base. As I've told you, the base can took away this proton, then the electrons will move over here to generate a double bond. Resultantly, this will leave as a good leaving group. So one can have this sort of, here is the vinylic functionality generated. One will get water, and we can get sodium halides, So this is how the supposed to be the final vinylic functionality carrying dye, vinyl sulfone based dye. So the R could be anything. This is the simple reaction in the presence of sodium hydroxide to give us vinyl sulfone based functionality. Then this can react further with the cellulosic fibers, as I've told you earlier. So these will be regarded as vinyl sulfone based dyes. I've given you an examples how the vinyl sulfones can be generated, how they can be connected with the dyes, so the dyes could become the vinyl sulfone based dyes. I've just given you a basic introduction about the vinyl sulfone dyes and try to explain with a bit simpler examples. In one of the next lectures, I will try to prepare vinyl sulfones from other 2 or 3 known methods as well, so you can comprehend about the preparation and synthesis of vinyl sulfone, and subsequently you may know the use of those vinyl sulfone for the preparation of vinyl sulfone based reactive dyes. So those vinyl sulfone based reactive dyes could be used as reactive dyes for the textile industry, where they could react with the cellulosic fiber through a nucleophilic reaction, resulting in the formation of a permanent bond, a permanent bond. The formation of permanent bond fixes the dye permanently, so that's why they are called reactive dyes. So in dyes course now, I've started off with simple basics about the dyes, how the dyes are different from the colorants, when a colorant becomes a dye. I've told you a colorant could be an organic compound. However, when you convert that organic compound into salt form, a water soluble colorant will become a dye. Then in case of dye, we have looked into Azo dyes. I've given you a very comprehensive and detailed lecture on dye Azo dyes, and in that very respect we have looked into dye azotization. We have looked into the couplers, how the couplers are produced, why we need couplers, how different shades and colors of dyes are produced. Then moving on from the Azo dyes, we moved into the reactive dyes, where I started off first, with simple reactive dyes, and I also introduced Cyanuric Fluoride based reactive dyes in my last lecture. And today's lecture I've continued with the reactive dyes and discussed the next class, that is vinyl sulfone based reactive dyes. I've given you a basic information, a background information, and then I've tried to prepare vinyl sulfones by two different methods, and I've given you an introduction that how the vinyl sulfone based dyes could react with cellulosic fiber, resulting in the formation of permanent bond. So this is how we have started off in color chemistry course, and we moved from basic simple dyes, then we discussed Azo dyes, we moved to reactive dyes. In reactive dyes we have moved to vinyl sulfone dyes. If you guys have any issues, any problems related to any concept, any topic I've discussed till to date, you may put your question in comment area, or you may approach me through WhatsApp group. I will be happy to respond at the earliest possibilities. I hope you people are enjoying to learn about the color chemistry, what is the basics, how those colors are prepared by using simple basic reactions, especially reactions of benzene, the electrophilic substitutions. Secondly, I've given you also the use of nucleophilic reactions at aromatic rings for the preparation of couplers, so that you can generate a library of dyes by using different couplers. So this is all about today's lecture. Again, if you have any question, any issue about today's lecture, just put your question in comment area. I will be happy to send my response at the earliest possible. Thank you very much for your kind attention. Assalamu alaikum.